let's say, for example, now you have a brand new laptop, or the laptop does not have an operating system. You either have the option of installing a Linux-based OS or a Windows OS or a Mac OS on it, right? Right, guys, so welcome back to another video, and as you all know, my name is Chinedu Mulan, aka and Mina is software engineer. So today again we talk about Docker. I know we've actually had a little bit of explanation on what Docker is and how you use Docker, especially if you're a developer developing applications. It can either be for a freestyle project or you're working in a company. I guess Docker, they save you a lot of time, especially when it comes to deployment, and also not just deployment. Also, if you're having the issue of, okay, it works on my machine, but it doesn't work on this other laptop, because as a developer, I guess we probably might have had this issue at one particular point in the journey, wherein I basically could develop an application on one operating system, but then when I move it to another one, it doesn't work. So I can remember at some point as well, the same thing happened to me. We developed, I think it was an API on a Windows operating system, and the database file system for Windows and MySQL, they have like a little bit of issues when you move it over to Linux-based operating system. So we had to figure out how to solve that issue and all. But by then, we never had an idea of what Docker was. So, all right. So today, like I say, we talk about Docker. So let's get right into the video. All right. So here are some of the things that we'll be talking about today. Like, I'll briefly explain again what Docker is, and from there, we'll talk about Docker images and Docker containers, because these are two most important topics when you come across anybody talking about Docker. You must hear something about, hey, Docker images or Docker containers. All right, so we get to understand what Docker images are and also what containers are and how they differ from each other. And then after we talk about images and container, we basically get to talk about Docker image layer. Yeah, that is a little bit out of the scope of this video, but I find I'm very important that somebody need to know, because I had a lot of problems understanding Docker image layer, and I hope I will be able to explain to you guys in a way that you guys would be able to understand, because the Docker image layer is very, very critical. It's a very critical topic that I believe every single person moving or wanting to start using Docker must understand, because you will not like run simple commands to build an image, and then you do not actually know how these image layer work or how the whole caching for Docker works. And then at the end of the video, we'll talk about what Dockerfiles are, because basically as developers, these are what the files that you'll be creating, and then when you execute a certain Docker command, you pass these Docker files to the command, and then the Docker runtime knows how to go about building the images from these Docker files. And so, yeah, so let us first of all talk about what exactly is Docker. So Docker basically, I have put them in simple terms. It is a technology that actually helps you build and deploy applications in a simple and straightforward manner. So from the definition, it says, Docker is a software platform that allows you to build, test, and deploy applications quickly. Yeah, take note of the word quickly, because prior to this time, if you're not a developer and then you don't develop, but let me say you HTML, CSS, and JavaScript application for deploy them on your server, you get for zip the whole folder, move on to using an FTP server, you move over to the server, and then, do a little bit of configuration and all. But with Docker, all you need for do is get your Docker file, write how you want for build the image, and then with the Docker file and then with the Docker build command, the Docker runtime actually takes the Docker file and then build an image. The image is what you deploy on your server, and then with just a simple Docker run command, boom, you spin up not just one, you can spin up multiple containers. So as you see from this diagram here, so the hardware can be like your normal PC, it can be an HP, Mac, or whatever PC you have. And then on top of the PC, we have our operating system. It can be a Windows operating system, a Linux-based operating system, whatever operating system you have. And then on top of the operating system, we install the Docker runtime, because basically, in order for us to be able to run Docker, we must have the Docker runtime installed, because it knows how to go about the API calls and all of that. So when we install the Docker runtime, with the Docker images that we will be building from the Docker files, we'll be able to like spin up multiple containers. This can be an image that runs the same application in different containers, or we can have different images for running different containers. Now, the way Docker don't help me basically is, prior to the time when I started using Docker, let me say, for example, if I want to use a MySQL database, I would definitely have to download the MySQL server, install MySQL Workbench, and make sure it is actually being installed on my host operating system, which takes a lot of space, takes a lot of memory, and all of that. So with Docker, basically, you can just download the MySQL image, spin up a Docker container, and then probably when you don't use them, you can just delete them as well, because I know say like you're not good for the user like almost all the time. So that is how like simple and helpful Docker is. So as you see, Docker packages software into standardized units called containers. We'll talk about containers that have everything that software needs to run, including your libraries, system tools, code, and runtime. So basically, the container, just as the name implies, it contains everything from your source code where you write, and also the dependencies that your application need. And let me say, if you're developing a Python application, you definitely know that, okay, the system that I'll be running this application on needs a Python runtime. So Python will be installed inside the container. And one misconception that people always have is Docker, it's not containers are not virtual machines, if I can say. They are just like lightweight systems, if I can put it that way, that runs on top of your host operating system. Unlike virtual machines, wherein you have your host operating system, and then with these different virtual machines, you can install other guest operating system. On a Windows PC, when you have an hypervisor, you can install a Mac, a Linux, and virtual machines take up a lot of computer memory and a lot of, but Docker doesn't. So that is it for what Docker is. So now let us look at Docker images, and what exactly are Docker images, and how do they fit into this topic. So from definition, they say a Docker image is a read-only template containing sets of instructions for creating a Docker container that can run on the Docker platform. Now, if we go back to the slide, you see we have the Docker runtime, and then on top of it, we have the Docker image. With the Docker image, now we can spin up multiple containers. So the image is basically like, let me say, the operating system of your application, if I can put it that way. Let's say, for example, now you have a brand new laptop, or the laptop does not have an operating system. You either have the option of installing a Linux-based OS, or a Windows OS, or a Mac OS on it, right? So for installing the operating system, you need an ISO file. So think of images as the ISO file that you get after you've built your Docker, after you've run a Docker build command, and then with your Docker file. So the images are just read only. You cannot edit them. The only way that you can make modifications to the Docker images is when you make modifications to the Docker file. So it says a Docker image is made up of a collection of files such as installation, application code, and dependencies required to configure a fully operational container environment. So basically, our Docker image contains our runtime. The runtime is basically what your application needs. Like I mentioned earlier, if you're developing a Python application, you definitely need a Python runtime. If you're developing a Node.js application, you definitely need a Node.js runtime, so on and so forth. So it contains your runtime, the source code, and also you must have dependencies that you install. Let's say, for example, you're developing a Django application. Now you need to install Django. You need to install some Python libraries. So these dependencies, you specify them inside the Docker file, and then when you run the Docker build command, it gives you the Docker image, and the Docker image images are made up of different layers, which we'll talk about in another slide. All right, so from Docker images, we get Docker containers, right? So a Docker container, as I mentioned earlier, not just like a virtual box, a small box that contains only the things that your application needs to run, right? So a Docker container is a self-contained runnable software application or service. It can either be an application or a service, whatever you want for column. So think of a container as a virtual box that holds everything that your app needs to run. Let's say the container basically, now inside it, every single thing your application need, they live, you understand? Now, the way that we can actually access these containers is when we expose a certain port. Now, you see this container here, so if this was a Node.js application, it would have my Node.js runtime, my source code, and then also my dependencies and every single thing that it needs. So Docker containers, basically, they have their own separate file system that is different from the host operating system file, file system. They have their own networking architecture. So this one container gets every single thing that it needs for make sure, say, the application run. And the only way we can access the application is by exposing a port. It can be like, say, let's say, for example, my application is running on port 5000. I can say, okay, inside my Docker file, I can specify, so, okay, I want to expose port 5000. And every other container that wants to communicate to this port, this container one, will definitely have to use port 5000, right? So from the Docker image, where we don't specify how we want for, like, make we Docker container them run, we can spin up multiple containers. Now, I use this Docker image. This can be one Docker image, and then you can get multiple containers from it. Let's say this was a Node.js Docker image. I can get Node.js app 1, Node.js app 2, Node.js app 3. Do you understand? So the containers basically has every single thing that your application needs, and the way that we can communicate to the container is by exposing a port, which we'll talk about in probably another video when we talk about Docker network and also Docker volumes, right? All right, so that brings us to Docker image layer. The reason why I decide for like talk on this topic is because Docker image layer is very important for you to understand, especially if you're new to the whole Docker architecture and all of that. So in Docker, an image is made up of a series of layers. And sorry, let me go back. Each layer represents a set of file system changes. Now, each layer inside your Docker image, they represent how frequent, you understand, changes they occur. Now, if you see from this diagram over here, so you see everything is being stacked. If you've done data structure and algorithm, you know what a stack is, right? Everything comes on top of each other, like you can have a deck of cards. Now, the base image is at the bottom of the stack. And then this side will get layer 1, layer 2, and layer 3. These are what we call the intermediate layers. Now, the base image layer, this last side, these are like read-only layer, because once I say, okay, I need a Node.js runtime, I can easily download a Node.js image from Docker Hub. We'll talk about Docker Hub later. Now, this Docker image has already been built by the Node.js Inc. or whatever. It can either be an official image or an unofficial image. I know, say, I'm definitely not going to be making changes to the base image, so it is at the bottom of the stack, because what happens is the more frequent you make changes, you understand, the more build time it takes. So if let's say, for example, you make a change here, every single thing so far inside the whole image has to be rebuilt again, you understand? Because it's kind of like a bottom top order, if I can put it that way. But let me say, if I make change on top of my container layer, the changes would only reflect on my container layer. Now, I can use the same cached version of these other layers, yeah? So the base layer is the starting point of an image, yeah? It often includes an operating system, an Alpine Linux, an Ubuntu, and every single essential system library. So let's say if I need a Node.js runtime now, Node.js have different images with different tags. We'll talk about these later. Now I can download any one of these images and say, okay, I'll need this one for being my base image because I'm building a Node.js application, or I'm building a React application, because we all know React runs on Node. And then when I have my base image, I have my intermediate layer. So the intermediate layer, basically each subsequent layer in the Dockerfile creates a new layer on top of the previous one. Now, basically the intermediate layer, now there they copy me dependencies, let's say, because I know my dependencies hardly change. It changes only when I install something, or probably when I uninstall something. Let's say now these changes in my my package.json file or my package log.json file, they occur very rarely, right? So as you can see from here, we have a change frequency from the lowest to the highest, right? Now this intermediate layer contains my what should I say, my dependencies. And also if I'm making a change to the system, let me say for example, most of the base images that we use now in Docker, they are being run as a root user, but basically I do not want to run my container as a root user, so which is a good practice when you talk about security in Docker. Probably in my intermediate layer, I can say, okay, I need for create a new user, and then give permission to every file inside my container to this new user, and then before I get my last command, I say, okay, switch to this user instead of using a root user. But we'll basically talk about this when we actually start writing our Docker scripts, yeah? And then the container layer, basically, this is a layer where writable changes occur. This layer allows us to modify the container file system during runtime. Let's say, for example, now, I have my source code, and my source code lives at the container layer because basically I make a lot of changes to my source code. Probably I want to incorporate new feature, I need to change the color of a button. I need for do a little bit of changes. So it is on top of the stack. So whenever I make a change on top of the container layer, the changes only reflect on that part. And then Docker has a caching system, so it does not have to rebuild the whole image again. So it uses a cached version of this one. But let's say now if I'm changing the base layer, so basically that I'm changing every single thing, so I have to rebuild the whole entire image again. So basically it is kind of important that you understand how Docker file system or Docker image layer works. So when we start writing our Docker scripts, you will not be confused as to why this is on top, or how some of these things come into play. All right, so lastly, let us talk a little bit about Docker files, which are very important. These are the files that we as developers will be creating. We can have different Docker files for different stages of the application. We can have one for development, one for pre-production, and one for production, because basically that is what I do. Now, say a Docker file is a script that we write in order to build Docker images, yeah? So it contains the set of instructions that specify how we want to assemble our Docker image step by step. So in the Docker file, we define the base image, install dependencies, add application code, configure settings, and many more. So now, if you see, this is just an example of the Docker image. So from the first line, we say from, and then we have a base image, and then with a tag, right? Every single image that you'll be building in Docker has to have a tag, so that you're going to say, okay, this was version 1 of my first source code. And then probably when you make a change, you do not want to use the old image again, you can get, okay, version 1.1, version 1.2. And then when you have a major release, you can say, okay, version 2.0, and then you release that one. So from here, we're specifying the base image. And then as you can see, these all, now we intermediate layer this. Now this one says, create a working directory, which is called app, and then you switch to the working directory. And then what we're doing now, we're copying our files. So you copy, you get the source, and then you get the destination. So the copy, basically they take file on we host system, and then moving it into the Docker container, and then we can do other configurations like, update with system, create a new user, give permission to this user. And then we have a last command, which is a cmd command. So the cmd command, basically, it is a command that runs whenever we try to spin up a Docker container, but basically we'll see this one in action when we actually start Dockerizing our application. So you say when you run a Docker build command with a Docker file, it creates a Docker image based on the defined instruction. So after we've written our Docker file, we use the Docker build command, and then we pass it a tag. And then what Docker does is, behind the scene, it builds an image for us. And then at the end of the day, we have an image based on what we've specified inside our Docker file. So let us look at an example of a Docker file. So now, on this side, as you can see, we're actually building a Python application. So from our base image, so from here we say we use the official Python image as the base image. So we say from Python 3.8. So that means we're using a Python 3.8, a slim version. So there are different versions. We can get the Python latest, which comes with every single thing. You have a slim version, they have ways in which they build these images. And then after we've specified our base image, we set the working directory basically. So we say create a working directory called /app, and then you switch into the working directory. So we're basically executing commands inside this /app directory, and then we're copying our files. So this is our source, and then also we want for copier. We're taking files from our host system to our container file system. So the dot specifies, okay, copy every single thing on my host system and then move it over to the container. And then so now we're actually installing dependencies. So basically, since this is a Python application, every Python application has a requirement.txt. So we do a pip install, and then we specify the requirements.txt. And now we're actually exposing a port, like I mentioned earlier. In order for us to be able to communicate with the container, we need to expose a port. Now, what happens is, after we've exposed, let's say, port 5000, any other container that wants to run will not be able to access port 5000 because it is being used by this container, unless we have to stop the container and then delete it. And now, this cmd command, basically, it defines the command to run the application. So whenever we spin up the container, this is the command that gets run. So here you can see that, okay, we're running a python app.py, which specify, okay, you run this Python app file, and whatever application it is, then it gets spins up. So Dockerfiles typically start with a base image. This is the foundation for your image. Often an operating system like Hyper, Linux, Ubuntu, or any other image provided by the Docker community. So just like we have Stack Overflow, we have GitHub, we also have Docker Hub, wherein people build images and then they deploy them to Docker. Let's say, for example, now if I need Nginx, I will just go on Docker Hub and then, download an Nginx image, and basically pass it some few environment variables. So I will not have to rebuild the whole entire image myself. So that is what we also do. Let's say, for example, I'm developing an application and I need every single person to check out my application. I can build a Docker image and then send it to Docker Hub and share the link to probably a friend. And then what they do is they download the Docker image, and then they can spin up my application with no time. All right, so I did a little bit of, it's kind of like a rough sketch. So from the Docker file, we have a Docker image, and then from the Docker image, we run our Docker containers. But basically, I hope these explanations were understandable for you guys, and I try to see how best I keep them as simple as possible. But don't worry, when we actually start creating our Docker files, you get familiar with some of these terms that I just talked about. All right, guys, so that is it for this video. And if you guys need any further explanation or anything, just let me know. And probably in the next video, we'll see how best we can take an application that we coded ourselves and then build a Docker image and then spin up a Docker container. Yeah, thank you very much.